Hi everybody, today I'm going to rewrite the opendir function of cc65 Apple to runtime from C to assembly. For this I'm going to use this test program I've written. Let it load. The program lists the devices and then opens a directory and lists the directory. So for example, I can list the /test directory this way, or this one, and it works very well. But if we look for it in the debug symbol file, we can see that it's more than 230 bytes long. And I suppose rewriting it in assembly is going to make it shorter, which is always a good thing to have. So I have here cc65's opendir file open. What does it do? First of all, it allocates a structure. If that fails, return null with nomm as an error. Otherwise, it checks whether we passed dot as a name, and if so, substitutes current working directory. By the way, this has a little bug. If name is dot, or if it is .test or anything, it's going to fail. But I guess Oliver Schmidt found that acceptable, as Prodos directories cannot start with a dot. So we'll keep it as is. Afterwards, we open the directory file, we read the key block, and we get the informations, update the directory structure with these informations, and return the directory structure here, so that we can pass it to readdir and read the contents of the directories. So if read fails, we are going to fall back through here and return with error invalid, in which case we have to close the directory, deallocate the structure, and return null. I think I'm going to do this function a little bit differently, because let me show you that. If I go and open, for example, the malloc function or the Apple II open function, we can see, not in this one, okay, but this one calls other one. So the alloc function, for example, uses 3 pointers in 0 page, and pointers in cc65 in 0 page are sparse. No, it's not here. Well, we have 4 of them. So I'm going to do it differently. First, I'm going to do everything I need to do with name. Then I can forget about the name parameter. Then I'm going to allocate the structure, and then I'm going to read the file. So, first thing of business is to create a new file and save it as opendir.s. And we are going to start with the standard header. We're going to do a procedure opendir, And this is what we are going to export. We are probably going to need to import symbols and zero-page symbols and some definitions. I'm quite sure we're going to need to include the definition of the Apple II definitions, the zero-page definitions, and let's say it's good for now. And we are going, we are going to import the functions we know we are going to need. So there are malloc, open, read, director no, which in assembly form has 3 underscores. We're going to need close, free, and os error, which is not a function but a variable. I'm probably forgetting some. We are going to need current working directory too. And we are going to need symbols for an ommem and an inval, which are defined in erno.inc. Good. Let me have that logically set. So open, read, and close go together, in my opinion, and malloc and free go together. It's cleaner this way. So let's go. When we arrive at opendir, we have the name parameter in the A and X registers. So the first order of business is to store them, because we are going to need them a few times. So let's store them in, for example, ptr1 and ptr1 plus 1, the high byte of ptr1. And import that symbol from 0 page. Then I'm going to do this first because it's easy. It doesn't include any allocations or function calls. So let's substitute the current working directory if needed. Current working directory, let's check what it is. It's not specific to Apple II. Okay, here it is. And it's a buffer of, so we will need its address, not its value. So let's first check for a dot. For this we are going to load indirect in pointer 1 at offset 0. And compare with the ASCII value of dot. Then if it's not a dot, we are good. We can skip the next part. And the next part will consist of opening the file or allocating, but I feel it's going to be easier to first open and then allocating. I'll explain why later. So now here, at that point, the first character of name is a dot, so we substitute with the address of current working directory. So So let's load it, the low byte and the high byte. And store it in pointer1. Okay, now we can open our file descriptor. We need to push the name parameter in the software stack, and then we have to set this parameter. So let's push name. The name is in pointer1, so we can just call push pointer1. I will need to import that. Then we load read only. Where is this defined? Probably in an include file. Yes, fcntl.inc. Oops. And let's check the prototype of open. And include it here. Flags is an integer and it's a variadic function. So it's an integer, but the high byte is 0, so I can just set x to 0. And then call the function, but it's a variadic function. And in variadic functions, the Y register will contain the number of bytes pushed to the stack. So I need to load how many bytes I have. It's 4. No, it's 2. I pushed only 2. But wait, there's something with variadic functions. Variadic functions always use sequential convention, which means that the rightmost parameter is not in AX registers, it's on the C stack. So instead of doing that, I have to push my flags, push A0, it pushes a 0 for X and the value of A. I've pushed 4 parameters, if I'm not mistaken. Yeah, so now I can jump to open, and then open returns an integer, and it returns -1 if it fails. So -1 is this. And also it returns an integer because it wants to be compatible with POSIX in its API, but on an Apple II you will never open more than 265 files, so I can just check the low byte. If it's FF, it means we failed. So if we failed, we have to return null. I'm going to handle that later. Otherwise, we now have our file descriptor in the A register, and we are going to need to put it in the directory structure, and we are going to push it as the read parameter. So I guess we are going to save it in the hardware stack. And comment. Now, if we are there, we can now allocate the structure. Let's do that. Malloc has one parameter and it's size of the structure. I'm going to need, the dir structure is defined here. I'm going to have to do an assembly declaration of this structure. So let's do that. Save it as dir.inc. So what is in dir.inc? It's a struct. It has fd, which is which is a word. It has entry length, which is a byte. Entries per block, same. And then it has a union of bytes. Two pages of bytes, and then a struct content, which contains pref block, sorry, it's dot byte. Pref block is 1 byte, no, 1 word. Next block is 1 word, and then we have entries defined as 1 byte, even though there's going to be more. Struct and union and struct. I need to tabulate that this way. That should be good. So now back to opendir.s. We have to allocate size of dir. So low word and high word. And allocate that. How does malloc work when it returns? It either returns 0 for null when it's out of heap space, and both registers will be 0. The 0 flags will be on if we fail, and if we don't, we are going to load an address that is not in 0 page, that is pointed to by pointer 2, and we finish by setting x, which means we can just test whether the 0 flags is set. If it's not, we succeeded. Shall I check for... Yeah, I'm going to handle mallocation failures here. Otherwise, we are going to come back and we'll read the directory. So let's start with allocation failures. If we couldn't allocate, but we have opened the directory, we have to get the file descriptor back. And close. Sorry. We have to load a 0 in X because once again close expect an integer. And then we set a nomen. And we jump to director now. And then we return null. So load 0 in A, in X, and return. Okay, we're good. By the way, if we didn't open, we want to return null, and that's exactly what we just did. So let's say that this is return null. Good. Done. Before reading the directory, I have to set its file descriptor field. And we're here straight back from malloc, so our structure pointer is in A and X. I'm going to save them in a 0-page pointer, and I'm going to reuse pointer 1 because we don't need name anymore. And yeah, so here that's not what we are doing. No, we are doing it. To store it, we need to write a word here with the high byte 0. So let's do it. At offset dir fd +1. And then save the low byte. We decrement y. We have to get our fd back here too. And store it there. Good. Now we are going to have to push this as a parameter to red. Oh, wait. Yeah, no, nothing. Let me think. We now have to push the bytes buffer. The bytes buffer is a few bytes after our dir pointer. So let's calculate that. And we are going to add it to pointer 1. We are going to clear carry first, otherwise there's enough by 1 lurking. And save that, because we now have to do the high byte. move the high byte into X and restore the low byte. And now we can push the bytes buffer for red. Now we have to push the size parameter, so that's quite easy. The size is size of dir bytes, and it's a word. And we can now call read. And keep commanding. So, what does red do? What does it return? It returns the size. So we have to check that we have, yeah, I think it was written here, I'm stupid. We have to check that we read the correct number of bytes. So let's compare what's in X. Is it that? If not, we had a read error. And let's compare the low byte. And if it's not good, we have a read error. Yeah, no, you know what, I'm going to handle the read error here. So if it's equal, red is okay. And here we have our handling code. And here we have our read success code. So what do we do if red failed? If red failed, we have to set a inval, close the directory, free the structure, and return null. So first, let's handle that. Let's load OS error, and if it's not 0, don't set an error. Otherwise, load inval and jump to director now. Now we have to close the directory file. For this we have to get it from our pointer, which is pointer 1. And we have to load it from offset 0. Wait, there's something. Red is going to change our pointer. It's going to fuck up our pointer. So before calling read, I have to save our dir structure pointer. I'm going to do that on the stack. So let's do it before we pushed anything else. That read is going to unstack, to pop from the stack. Let's do it right here. Okay, back there. Now we have, of course, to restore our pointer. And we're going to do it with the helper function optir1. Let's load the file descriptor in A and a 0 in the high byte of the file descriptor. And jump to close. Afterwards, we have to freeze the directory. Which is here. And now we have to return null. Oh, it's already defined here. I hope it's close enough. Oh, it's going to be close enough because I'm going to jump anyway, not branch. Okay, so this error pass is handled. Now let's say red has succeeded. We are going to populate these. So let's go grab the values in the bytes buffer. Wait, pointer 1 points to the dir structure and we want to point to the bytes inside the structure, so it's 23 plus the offset of bytes in the struct. We load that. This is entry length, and then we store it. No. If we store it already in entry length, we are going to have to change our Y register to point there, and then we're going to have to point Y there, and then we're going to have to point it there, and it's going to be annoying because this one is just after this one. So we're just going to back up entry length. Okay. Back it up, and then we're going to increment Y and load the byte at that new offset, which is now entries per block. And we can now store them. At that offset, so we change Y, put it in the entries per block, and we store entries per block here, and then we restore entry length. go to entry length just 1 byte before, so I can just decrement y, but I'm going to make sure this doesn't change. So it entry length equal, there's no hashtag in the assets, dear entries per block -1. And we store entries per block, no, entry length. We're done for that, and we have to skip directory header entry. Which is at current entry. Where is current entry? Did I forget current entry? I totally did. Oh. Wait. So I can still spare a little bit if I do it the other way. Start with entries per block. Yeah. Then decrement y, do entry length. Let's change the assert for it to be more logical. And here instead we increment y, and now we can increment y again. First let's assert that current entry is 1 byte after entries per block. Load 1 and store it to pointer 1. Okay, and now we can return our pointer. And I think we are done. Let's check. We are not done. Unknown symbol or scope dear. I forgot to include the file I just created. Also, let's do that logically. Yeah, good. So lines here, I missed something. Oh yeah, assert or error. I forgot some imports. And there's an error. So first import what I forgot to import. Pop ptr1. Push ax. Push 0. Almost there. Here I have a typo. Yeah. Sorry. 2. Did I forget to import it? No, I did. result external. What? Okay, it with two of them, sorry. Good. So let's test this and trace the execution because I will want to check where it goes wrong, if it goes wrong. I can trace just at the right moment. Let's load the test directory. This is not going well. Okay, let's see what went wrong. I'm going to use my debug help tool, which allows me to add debug symbols to a MAME trace. As you can see, the trace generated by MAME has 0 symbols. It's not very helpful. And we have our symbols here. So this tool merges everything together and makes me something more readable. I can search for the jump to opendir and see how it goes from there. So, first of all, we store into pointer1. Pointer1 has other symbols, so the symbols are fucked, but we know it's 88 and 89. And then we compare with a dot, and it's not a dot, so we are going to push our directory here. Okay. Read-only. Should be, that changes nothing, but it's better. Jump to open, and then compare and return null if it's null. So, let's keep the internal functions. We are back in opendir. We push wait, what is that? Yeah, or read-only. We push Y and we open. So what happens in open? Let's see. After the return, we are returned with A03 and X0, so it means open succeeded and the file descriptor is 3. We compare with FF and we don't go to return null, we back up our file descriptor, and now we are going to allocate the size of dir, which seems to be okay. 2 in the high word means 512 bytes plus 5. The plus 5s are these ones, so it's good. And we jump to malloc. What happens in malloc? We are returned with x36 and a55, so this is okay. Malloc succeeded. So we're here now. We store that to pointer1 and we back it up. Then line 79. What did I do here? Why load a 0? It it should not have been 0. Yes, it is 0 because it's a high byte. Then I decrement, I get FD back, and I store it to pointer 1. Let's verify that. I store it, decrement, I push it, it's 3, and why do I store it and then I push it on line 87 for red. Okay. Now I'm calculating the buffer address, adding it to the pointer and pushing it. Okay, let's check what we push. It's here, push AX. It seems good, 365A. What was our pointer already? Yes, 55 plus 5 equals 5A, so we are good. Okay, and then we load two in the high byte, 0 in the low byte, it's 512, and we read that. Okay, so what happens in red? Let's see. We come back from red with, okay, we have red 0200 bytes, we are good. Line 103. So 103, we don't jump to error, we compare A to 0, and if it's the same, we go to line 192, because red is okay. Okay. So then we are going to load from our pointer the entries per block. It's 18. I have no idea if that's normal. Let's suppose it is. And we save that. Then we load entry length. Here, line 130. And it's 0. That's not normal at all. Why is not good? Yeah, it's good. X24 plus 5 is 0x29. And then 28, yeah, it's good. I'm still surprised that entry length is supposed to be 0. Let me understand what I did wrong here. We store entry length at okay. and then we get entries per block back, line 139, it's 18, and we store entries per block. Okay. Yeah, 2 and 3, that's good. And then we increment y, load 1, and store out of set 4, which is current entry. Let's just double check my structure declaration. FD and 3 lengths, entries per block, current entry. Okay, that should be good. And then we load. Okay, so I don't understand what's going wrong here. So we're going to try something else. First, I'm going to read it again. Entries per block is 24. We decrement and we have entry lengths. Then we store entry lengths. Then we store entries per block. Then we skip directory entry. Oh god, I don't understand what's going wrong here. Oh god, I know what's going wrong here. I absolutely forgot. Read OK. Read. Yeah, I forgot that. So I wrote whatever, wherever. Let's try again. I should have. Oh, wait a minute. 130. Let's check. Yeah, it's not the same. Okay, it's probably something like that. Nope, wait. Okay. So, aha, seems to work. Let's try on the other floppy. Good. So the main cut path works. Now let's try the different cut passes. First we have the dot case. Let's change that here. And test again. And trace in case things go wrong. It does work. And if I open the other floppy, it should use dot, which is still pointing to /test. We are good. So the dot case work. Let's try the non-existent path. And also trace, in case it goes wrong. Let's trace first and go. Empty, so it failed. Let's check how. Where is this failure mode? I don't remember. It's when open fails, which is the first error here. So let's go to line 48. We do have FF here. So we are jumping to opendir plus 58, which is return null at line 67. That's it, we return null and it's good. Great. So put back correct path here. Here. And now we have to check for a rate failure. So the easiest way to do it is just to feed a wrong parameter in the function. So instead of pushing the correct FD, we are going to push something else. Rebuild cc65's and trace again. We're going to trace to check our error path. Still empty, that's good. And let's go to line 103. Did we read 512 bytes? No, we did not. We read -1 bytes. So we are going to set our no. That's good. Then we get our pointer back because at line 116 we have to close the file descriptor. We get it back here, it's 3, and we jump to close. After closing, we have to free the directory. I guess we do. Yes. And then we load null and return. Perfect. So this is good if we can't read. And what's left to check the allocation failure. Here also the best is going to be to try to allocate something much too big, like yeah, it's probably much more than we can allocate. Let's try that. empty. We couldn't allocate, I suppose. So we back from allocate at line 5. And we have a null as a return value for malloc. In which case, what do? We fail to allocate, so we have to close the file. We close the file. Then we load Erno. And then we return null, so it's good. Let's put back the real values here. Make sure I didn't leave any test. No, sorry, I need to debug first. And let's make sure everything works. It does. Other floppy. It does. /RAM. It does, but it's really empty. Okay, so we're good to go. We can now make a pull request. So let's open a new branch. Let's add the new files. Let's remove the old file. Oh, I didn't even check the size gain. It's, oh, nice, 173, so we were at 231. Oops. 58 bytes, not too bad. And open a pull request. And we're done. Thank you for watching.